Cars are true wonders from engineering, not only because they have a very good system in the engine and also very safe airbags. Today we're going to focus on the damping system or suspension. The suspension consists of 4 dampers, each one with a spring. So every damper is located at each wheel. The dampers minimize the bumpiness of the roads so that you don't feel how rough is the path. Otherwise, you will feel every hole in the path and every stop, you would feel everything from the ground. Here we have a simplified version of a free body diagram of the car. The forces acting include the force from the road, which is pointing upwards, the force from the spring, pointing downwards, and the force from the damper, pointing also downwards. For this problem situation, we are asked to find the P and K constant for a car that weighs around 1000 kilograms and has an oscillation period of about 1 second. The problem mentions that at time equals 0 second, the displacement is about of 0.1 meter, and that it has to have a reduction at time equals 1 second of about 80%. So, at time equals 1 second, the displacement must be 0.2 of the original value. Substituting that value into the formula again, we found out that A is repeated on both sides of the equation, so it gets cancelled. After that, we are left with Euler's number. In order to get rid of the E, we need to use properties of natural logarithms. So, we apply that, and we are left only with the natural logarithm on one side of 0.2, and on the other side, we are left with B, so we can isolate it. Worth mentioning that B is times 4, because as we mentioned, cars have 4 dampers. So we're going to calculate for the whole system and then divide by 4. So we need to isolate 4B. After isolating 4B and making some substitutions with our data, we found out that the damping constant for the 4 dampers is of 3218 87.875 kilogram over second, and an individual damper has a constant of 804.7190 kilograms per second. After finding the B constant, we're ready to find the K constant. We make use of the angular frequency equation for damper in order to perform that. We also know that the angular frequency is of 2 pi over the period. We change that into our formula and we only have to isolate for K. After making some arrangement, we found, and some substitution with our data, we found out that 4K, or the total spring constant for the car, is about of 42,068.70 newtons per meter, and that each spring is about 10,517.17 newtons per meter. According to car manufacturers, common K constants in Newton per meter have values between 16,000 and 80,000 newtons per meter. On the other hand, B constant in kilograms per second has reasonable values between 1,000 and 21,000. However, these values are for average size cars that weigh around 1,700 kilograms. In comparison to our values and considering our car weighs 1,000 kilograms, these values would make sense for a small compact car. You can now appreciate how the suspension is crucial for every car and how it manages to balance the car along the road. It's a very important component that makes the car a true marvel from engineering. Thanks.